Hey, what's going on, everyone out there? My name is Rosendo Pili. I am from MLH, as you know, or may not know. I'm actually the customer success manager here at Major League Hacking, and I do a ton of great stuff with some of our awesome sponsors, folks that come over and provide a ton of awesome resources for the folks that participate at our MLH hackathon. So really today, what we're going to be doing is we're going to be doing a great workshop, everything MATLAB related, anything you want to know, anything you need to know, any questions you want to ask, you definitely just drop them in chat, because I've got an expert coming on board that's going to have all of the answers that you need. And, you know, not to put too much pressure on Connell, who I'll be dropping on the live stream very shortly, but he is a very intelligent person. Don't take my word for it. You're about to find out. If y'all are out in the chat, definitely feel free to drop your location, say hi, you know, anything you want, you know, just drop it in there. Any questions you have, we'll be monitoring the chat at all times throughout the workshop. So just make sure, you know, you leave anything there, and we'll get to it when we can. If you have yet to register for the event, make sure you do so. That's the link right there. You're going to get some cool, like, I guess you'll get some cool notifications about the event ongoing currently. But yep, that's pretty much it. Bonjour to you as well. I really appreciate y'all joining us today. As I mentioned before, we have a great workshop scheduled. I'm going to go ahead and bring Connell on stream so y'all can meet him. And with that being said, I'll also stop this banner because we're not starting soon. We've already started. And without any further ado, I'll go ahead and introduce y'all to Connell D'Souza. How's it going, Connell?
Hello, everyone. Rosendo, thank you so much for that extremely kind introduction.
No worries.
I hope I can live up to it.
I have no doubt that you will. Once again, y'all, I'm going to leave y'all in the capable hands of Connell here. And yeah, anything you need, I'll be in the back of the studio. And anything that y'all want to say, feel free to drop it in the chat once again, y'all. All
right. Awesome. Well, let me just get my screen all shared up, and we should be good to go. All right, cool. So I'm hoping all of y'all can see my screen. Just to give you a little bit of an introduction about myself. My name's Connell D'Souza. I work on the student programs team here at the MathWorks in the education marketing department. And part of what my job is and my team's job is we try to help students and people that are learning at different levels. People that are trying to learn how to use MATLAB. We're trying to help you get the best out of our tools. So over the next, I'm going to say 30, 45 minutes or so, I'm going to talk a little bit about how MATLAB can help you for hackathons. And, again, I want to keep this as freeform and flowing as possible. So if you have any questions, please pop them into the chat. I'll be happy to answer them as and when I can through this presentation. Okay, so Quick agenda for what we're going to cover today. We're going to talk a little bit about deep learning with MATLAB. I'm sure all of y'all have heard about deep learning. Not sure how many of y'all have tried to work it before or tried to work with it before, but I'm going to introduce you to some tools that we have in the MATLAB ecosystem that can help you with getting started with deep learning. We're going to talk a little bit about some hackathon user stories. Let's see what some of your peers and some other people that have taken part in hackathons have used MATLAB to build some cool hacks. And then we'll point you to some resources that y'all can use this weekend to hopefully use MATLAB for the hackathon and win that best use of MATLAB prize, which is a pretty cool swag bag from the MathWorks. All right, so let's jump right in. Let's not waste any time. I think the first thing that I want to highlight is deep learning is a key technology. That's driving the AI megatrend, right? So AI is, artificial intelligence and AI has been around for years at this point, from the 1950s, so to say. And it's obviously been getting better as our ability to do computation gets better. We've got faster computers now, we've got more advanced technology, and so on and so forth. So artificial intelligence as a whole is any technique that enables machines to mimic human intelligence, right? So as humans, we underestimate the capability of our brain to be able to run these massive computations really quickly. And artificial intelligence is trying to impart that kind of knowledge into a computer or into a machine. As we move forward in time, machine learning started coming up, and machine learning is essentially a subset of artificial intelligence, if you will, and it's got a bunch of statistical methods that enable machines to learn tasks without explicitly programming it. So essentially, what we're moving into the times where you don't need a programmer to sit and tell a machine what to do. I'm sure all of you are familiar with with do while statements or if else statements and stuff like that. But whenever you're building code with those kind of statements, it's you as the programmer that's putting in these instructions, so to say, to the computer. With the advent of machine learning, we figured out how to start using data to tell the computer what to do. So it basically looks at a bunch of data and then is able to identify trends and stuff from there. Okay, and then the next advent was sort of deep learning, where we started taking those machine learning networks that we had and just adding more layers to the network, right? And earlier, what would happen is you'd have to give a machine learning network features, right? You couldn't just give it a raw data dump and say, okay, learn something from this. You had to sort of pass through the data, identify some features, and then feed it to the network. Deep learning has taken that to the next level, where you can just feed in a giant dump of data, and the network is able to learn over time because of the fact that it's got these multiple layers, and we'll talk about that in a quick second. Okay, so whether you like it or not, deep learning is a part of our everyday lives. I'm sure all of y'all have used some sort of smart speaker. I love I have one of the Apple HomePods at home, and it's amazing. Like it helps me schedule everything that I want to do. But a lot of the underlying technology that works on speaker recognitions for these smart speakers is using deep learning. Similarly with face detection and automated driving, I'm sure all of you have heard of this. The self-driving cars that are coming out and new automated driving or driver assistance features that are being added, deep learning is playing a big part in how that gets rolled out to the masses as well. So here are some applications. Now, as I said, all you need to feed into these deep learning networks is data, right? That data could be in any form. It could be in the form of images, could be in the form of videos, could be in the form of signals, could be in the form of text data, numeric data, so on and so forth. So these are a couple of applications that we have. The first one is this neural network called YOLO V2. And now, obviously, over the course of time, we've got YOLO V3 and V4 and V5. And essentially what YOLO V2 is, it's an object detection neural network, right? So as you can see, we have a camera mounted on a car that's driving around the city. And you can see it's able to identify those street signs, right? This is what we call an object detection problem. It's not just identifying what that particular area of interest is. So in this case, street signs, but it's also able to sort of tell you where in the image is, or where relative to you this is. So as you can, as I'm talking about this, I'm sure you can imagine how important this feature is to a self-driving car, right? Being able to identify where the signs are, being able to identify where a pedestrian is versus where another car is versus where trees are and lane lines and so on and so forth. The next application that we see is something called semantic segmentation. And this is again used a lot in self-driving, self-driving technology, automated driving technology, where as you see, you've got a network that's able to segment, as the name suggests, segment the areas of interest in your image or video stream. So you can see the road is being marked with a green area, cars are being marked with blue, and so on and so forth. So these are some examples of how you can use deep learning with images and video streams. Let me just go to the next slide. As you remember, I spoke about deep learning for signal processing, right? So for on the left, what we have is a classic example of some kind of human activity detector. So say you have your cell phone, or you have some sort of sensor. It could be some sort of wearable tech, right? It could be like a smart watch, or your cell phone, or if you have some kind of advanced sensors on board your person. What the deep learning network is able to do is able to classify the signal. So obviously the sensors that you have in that device are giving you some sort of signal data, right? Whether it's a GPS signal or a accelerometer signal or something like that. We're able to train this network to identify this human activity, right? And say, okay, if the signal looks like this, the person's probably walking upstairs, or walking up a flight of stairs, or walking down, or laying down, and so on and so forth, right? So another pretty common application that you've probably seen in your day-to-day life, but signal classification using LSTM. So LSTMs are long short-term memory networks, and we'll talk a little bit about them in the software demo in a quick minute. The next one is speech recognition. I'm not sure if you can hear what he's saying, but my colleague Gabriele, who's in the picture there, is essentially saying a bunch of words, and the deep learning network is able to identify what he's saying based on the shape of the signal. So essentially, the technology here is we feed in spectral images of the signal, and we pass it through some sort of a network that can identify these images. So it's able to identify different features in the image, and then tell you that it is, that corresponds to a particular word or a particular phrase. Okay, so let's talk about how does deep learning work, right? So deep learning uses these things called neural networks, and you've heard me drop the term a couple of times, but essentially a neural network is very similar in construction to the way the human brain is constructed, right? So you've probably heard of the term neurons. Neurons are nervous system cells, if you will. The deep learning neural network also consists of neurons, and it consists of neurons in layers. Okay, and then these layers, there are various combinations of these layers that we can take a look at. You've probably heard the terms convolution. You've heard the term fully connected layer, ReLU, etc., regression, so on and so forth. So these neurons are connected in combinations of these layers to build these networks up, right? Now each of these neurons consists of some learnable parameters, and these learnable parameters are called weights and biases. So essentially, when an input comes in, it activates the neuron, and so let's give you an example. If you're training a neural network to identify, say, a cat versus a dog, you essentially feed the network a bunch of pictures of cats and say, okay, these are all cats. Now, what will happen is as that pixel level data moves to the network, it's going to start activating these weights and biases and modifying them. Okay, so what it'll do is it'll go from the start of the network to the end, and the network will give you a prediction based on what it thinks it is, right? Then you compare that prediction from the network with the ground truth, or the data that you've given it at the start, and if the prediction, so the prediction comes out in the format of a percentage. So it'll say the network will say, oh, I'm like 60% sure it's a cat, 40% sure it's a dog, or 40% sure it's something else, right? Um, Now, if the highest percentage is what corresponds to the ground truth, it will sort of reward itself and update its weights and biases, right? So this is the process of how a neural network gets trained. And then you've got some hyperparameters like learning rate, number of epochs. So an epoch is how many times the network gets trained. You've got mini batch sizes, which talks about how big the data set is as it goes through, and so on and so forth. Okay, so as I said, the applications of deep learning are very versatile, as we saw at the start. Um, um, the most commonly used, so most of deep learning essentially boils down to two problems, right? You either got a classification problem or a regression problem. Now, what is the primary difference between a classification or a regression problem? So in classification, your output is categorical. So say you have, I'm not sure how many of y'all have seen the show Silicon Valley, right? There was this TV comedy show a while ago that came out called Silicon Valley. In one of the episodes, one of the characters in the show's name is Jin Yang, and he builds this hot dog, not hot dog app, right? So essentially, it's saying, okay, this is a hot dog or this is not a hot dog. So that is an example of a classification problem where you've got categorical outputs, right? It's either hot dog or not a hot dog. It's a cat or a dog, or it's a particular kind of flower or another particular kind of fruit, right? So where your output is categorical, you have what we call classification. The next type is regression. Now, regression is when you've got when your output is some numerical or continuous value, right? So think of things like say you want to predict chickenpox cases, or you want to predict you want to predict like stock prices, anything that's got like a numerical output to it. So say, given this particular set of inputs, what is some numerical output that's coming out? And that's what we classify as a regression problem. So essentially, most of deep learning boils down to these two problems, right? And these are the two problems we're trying to solve. So there are two different approaches for deep learning. At least, the first one is to develop and train a deep neural network from scratch. So you saw those layers of neurons that we put together. You essentially go in and design those layers as for how you want it, build the network up from scratch, and then you train it. Okay. Now, the caveat is with this, your network has no background information. It knows nothing. It's like an infant child. It absolutely knows nothing, right? And you're trying to essentially impart a lot of knowledge to it. The next approach is what we call transfer learning. So what transfer learning does is you take an available network that's already been trained to identify some X number of categories. Now, the thing with this network that's already been trained is all of these layers have very fine-tuned weights and biases, right? And these layers are able to identify features. So they're able to identify curves. They're able to identify straight lines. They're able to identify changes in color, like all of those kind of features. So what you do is essentially you take the network's ability to identify these features, and then attach it to saying, okay, now this particular curve corresponds to this new set of objects of interest, right? And essentially, essentially, what's happening is you're taking a network that already knows how to identify features, but then attaching a new set of classes to it, if you will, at the end. That's saying, okay, this particular curve that you thought was a cat is now an apple, right? And it's it's essentially these networks have some pre-knowledge. The advantage with this is that you don't have to design a network from scratch. You can use something that someone that's probably an expert in this field has built. And then B, you don't require as much data because you don't have to teach the network features. You just have to correspond those features that it already knows to the new objects of interest that you're trying to teach the network, right? So these are two approaches to deep learning. Okay. Next, we talk about the deep learning workflow. But before we go into that, I'm going to stop and look into the chat to see if we've got any questions for us. Okay, so the first question is from Suyash, who says, I want to ask if I should use MATLAB or Unity for making a gun. I'm guessing Tourette model with. I'm not sure when you say ML, do you mean MATLAB or machine learning? Um, but it's hard to choose between the two, or should I just get started? So Unity and MATLAB are two very different tools that do different things. Unity, and this may just be my ignorance in the subject, but as far as I know, Unity is a rendering environment, right? It's an environment builder, so you can sort of build worlds, you can build games, and so on and so forth. You still have to do the physics solving somewhere, right? The Because if you have an interaction, say you have a gun turret, right? The gun turret has to sort of rotate or move in a circle. You have to be able to model that physics in some way. I am not sure how to do that in Unity, but I know that you can do that through Simulink, which is, so in Simulink you would build a simulation model. Simulink is another product that we have. But you can use you can use Simulink to sort of model the physics of it and then visualize it in Unity. So I'd say you can. I don't think it's an either or problem. I think it's use both of them together, kind of a deal, right? The next question is deep learning more intelligent than machine learning? I would say yes, but it depends on what you mean by intelligence. Deep learning is more intelligent in the sense that it is able to identify or is able to learn things from data directly, whereas with machine learning you still have to like extract features in some way, right? So there are obviously trade-offs to both. Deep learning, with deep learning you need a lot more compute power, whereas machine learning not as much, because there's not as many computations that are happening, right? So think about each of those. The thing that makes machine learning different from deep learning is the number of layers. Okay, now each of those neurons are essentially performing some sort of convolution. So as you increase the number of neurons and as you increase the number of layers, you've got more computation that needs to happen. So, which is why you need things like GPUs and stuff like that for deep learning, but you may not need it for machine learning. So, I'd say I don't know if one's more intelligent than the other, but I think they're both different tools in your toolbox that you use depending on what your application is, right? Very often people try to their first option is to go and use deep learning, where it may be an overkill for what you're trying to do if it's a simple problem. So I think that's something that's a call that the designer has to make based on what their application is. And then Deep asks a question: can we use MATLAB if we don't know about AI or machine learning? Yes, if you hang on till the end of the presentation, I'll show you some resources that can not just help you get started with using MATLAB for machine learning and deep learning, but also for just a whole host of other things. Like MATLAB's, we've got somewhere in the range of, I'm going to say, like 60 plus toolboxes, and each toolbox is for specific applications like signal processing, control systems, so on and so forth. So there's a lot of things that you can use MATLAB for other than just AI and machine learning. Okay, so let's move ahead, and we'll come back to some questions in a little bit. Okay, so let's talk about the deep learning workflow, right? So the deep learning workflow, whenever you're trying to build a deep learning model for a particular application, you sort of go through these 4 steps, no matter what the application is, right? The first thing that you have to do is you have to have data. You have to have lots of data for deep learning, right? So you start on the left-hand side with accessing and exploring data, and MATLAB allows you to access data from a number of file types. So whether it's CSV files or websites, what have you, files that are on your computer, or you can also access databases. So a very popular workflow, because of the amount of data that you need for deep learning, is to use web services like AWS or Azure or what have you to store your data in the cloud. So you're not roaming around with hard disks full of these terabytes of data very often. So MATLAB gives you these hooks where you can just hook up to an AWS instance and sort of stream your data in from there without actually downloading it onto your computer. So that gives you a lot of flexibility that way. Another application is through sensors. So a very common application with deep learning now, especially in the industrial and manufacturing space, is this thing called predictive maintenance. So predictive maintenance is essentially what happens is, if any of you have worked in a factory or know about how factories function, all factories go through periods of downtime because they have to either replace parts or fix some machines or make adjustments to things and so on and so forth. So what people have started doing now is they've outfitted their factories and their machines with a large number of sensors, and essentially based on this, and they keep collecting the sensor data over as long as the machines are running and so on and so forth. And over the course of time, you generate enough data for yourself where you're able to understand what this sensor data looks like right before a part is going to fail or right before a particular machine is going to fail. So they essentially build these deep learning models based on the sensor data that they're getting to say that, okay, I need to replace this particular part in 2 months or this particular part in 3 months. And now what happens is you're able to plan better and say, okay, I need to shut down my factory for so-and-so date, but I can change 5 parts because I know that the next one's going to fail, maybe 3 or 4 days later, right? So essentially, predictive maintenance is another big area of deep learning. Okay, now that you've been able to access and explore your data, see what your data looks like, obviously MATLAB has great visualization tools to plot data and view different sources and so on and so forth. But then you have to do some pre-processing. You have to be able to clean up your data, label it. Like in the case of cats and dogs, or telling a network with cats, you have to tell the network that this is a picture of a cat so that it can learn from there, right? So you have to label that data, and then you also have to very often import reference models from outside. So import like a network that's already built. So MATLAB allows you to do all of these kind of things. Another big thing is data augmentation, right? Very often, if you have like 50 images of a cat, you want your network to see as many different kinds of images as possible with things like different lighting conditions, different skew angles, so that the cat is not the center of the picture. It's kind of skewed. You're looking at different angles of the cat and so on, because that makes your network more robust. So MATLAB has some tools that can help you augment your data, but also transform it. So sort of twist it and shape it in different ways that make your network more robust. Okay. Then we can also talk about developing predictive models. So that's when you actually design your network, tune it, and train it. And we've got the ability to, through MATLAB directly connect to a GPU if you've got it on your computer, as well as visualize different portions of your network, but also do this thing called hyperparameter tuning. And you can go and go and read on the internet about what hyperparameter tuning is. But it's essentially playing around with those hyperparameters like learning rates and epochs and so on and so forth to make sure that your network is the most accurate that it should be. And then finally, you can integrate it with other models and systems. So either create a desktop app where which calls this network under the hood. You can use enterprise scale systems. Put it on the cloud, so on and so forth. Hook it up with other languages like C++, with Python, Java, even Excel, if that's what you wish. And then also put it onto embedded devices and hardware. So you can program hardware like the NVIDIA Jetson or other kinds of deep learning enabled edge computing directly from the MATLAB environment. So you don't have to learn any other language. You can just sort of work in the one environment that we provide you. Okay. So we're going to do a quick software demonstration. I'm going to stop real quick for some questions again, just to see where we're at. I'm not sure I understand this question. Can we say DL is the machine learning something by itself, not just? I'm not sure I understand the question. If you can clarify that, I can answer that for you. But moving on to the next one. How do you draw a tent map graph in MATLAB or a sign map? Let's hop into MATLAB and I'll show you what we can do. But essentially, if you go to the plots tab up here, we don't have any variables in here, but this should give you a whole list of plots that you need. So I'm guessing what you're looking for is if it's a tent map, so to say. I'm guessing it's a three-dimensional mesh or a surf plot. So I just take a look at the documentation for either surf or mesh, and you should be able to figure out how to do that. And if you need some help, you can always get in touch with me later. Or another place where you can go and ask is MATLAB Answers, which is, there's a community over there. Someone's already probably done this before, and they'll be able to help you out. But yeah, this is the whole area of this is the whole sort of plot gallery, if you will, that we can use. Okay, so anyway, to show you a quick example of how easy it is to build machine learning applications in MATLAB, I'm going to go over and open up the documentation real quick. And in the documentation, as you can see, each of these is a toolbox. So you've got toolboxes for communications, computer vision, etc., etc., etc. What I'm going to look at particularly today, just for the sake of this demo, is the deep learning toolbox, which is, if I can find it, here we go. So the deep learning toolbox. So this is a toolbox in MATLAB. It's got a bunch of these neural networks and pre-trained models and so on and so forth. And we can get started. My favorite way to get started with MATLAB is to go into the examples tab, because each of these examples are, something you can just take and use directly. So as you can see, we've got some examples on how you can stream in information from a webcam and then classify it using deep learning. There's some examples on transfer learning and so on and so forth. But what we're going to look at is a time series example. So this was that signals example that we saw earlier. This is similar to that. It just classifies ECG signals. But what I'm going to look at is let me just search real quick. For some reason my keyboard won't type, but we'll figure this out. Just give me 1 second. So as you can see, there's a whole bunch of examples. For some reason, my I'm not able to type into this. I'm going to have to actually look, which is not fun. But give me a second. Okay, I got the command, so no, this is not the right data set, though. We got my computer working, so we're good. There we go. All right, I apologize for that little bit of a delay, but that's what happens when you're trying to do live demos. But anyway, what we're looking at here is we're looking at doing some sort of forecasting, some sort of time series forecasting, right? Which is and we're going to use an app called the Deep Network Designer, which is essentially an app to build these networks, right? So what we mean by time series data is any data that's sort of rooted in time, right? So think of things like a signal, a signal that has some time component to it, like your stock market data. It's data based on time. This particular data set that we're going to use is the chickenpox data set. It's a data set that comes shipped with the toolbox. But I'm going to run this section real quick and show you what the data looks like. So as you can see, it's just the monthly cases of chickenpox by month. So there's a time component to it, and there's a numeric component in terms of the number of cases. Okay, so as you can see, there's some seasonality to this data. There are some months where it's higher, some months where it's lower. So this is very typical of any sort of caseload data that we're familiar with, right? So essentially, what we're trying to do here is so we've got data for 500 months. We're trying to predict what these chickenpox cases will look like, in the say 502nd month, 520th month, so on and so forth, right? So essentially we're trying to build a model that can help us predict what this case will look like in the future. Okay. Now, as we said, the first thing that we need to do, or the first step, is to sort of pre-process our data, right? Pre-process and access and pre-process our data. So we're able to access the data, but there's a very important element with deep learning, and that is making sure that your network is not overfit, or is not overfitted to a particular data set. And the way you do that is you always you always make two sets of data. You make one data set to train your network, and then one data set to validate or test it. And you want to make sure that both of these data sets are independent of each other, and your network has never seen your validation data while it's training. Because if your data is looking at the validation data while it's training, it's going to be able to identify trends in your validation data, and it'll tell you, your conclusion will be that, my network's doing extremely well because it's it's identifying, it's giving me like a 95% accuracy on my validation set. But in reality, your network has learned from the validation set, right? So you want to keep these two sets different. So what we're doing here is we're essentially taking our 500 data points, and we're splitting it up into a test set and a train set and a test or validation set. And we're going to do a 90-10 split. So 90% of the data goes into the training set, and 10% goes into the test set. So that's what these two lines of code are doing here. The next thing that we have to do is we have to standardize it, right? And this is a pretty common step in statistics, right? Where you take a data set and then you essentially standardize it around a mean, right? So you take the mean of the whole data set, subtract it from the actual value, and then divide it by your standard deviation. And that's essentially what's happening here. So I'm going to run this section real quick again. Now we have to we have to create these things called predictors and responses. So your predictor is kind of what input you're giving into to the network, right? So in our case, our predictor is if we want to identify the number of chickenpox cases in month, say 51, we need to use month 50's data to predict that, right? So essentially our predictor set is all of the our entire training set minus the last element of that set, because we're going to use all the previous ones to we're going to use the previous element to predict the next one. And our response set, so to say, is element number 2 to the end, which is essentially what these two lines of code are doing, right? And if anyone, if I'm going too fast or anyone has any questions, please pop them in the chat. I'm trying to monitor the chat as we go along. Okay. next, what we've got is so MATLAB has created these things called data stores. So we've got data stores are a way to essentially work with large chunks of data. Now, in this case, we only have 500 elements, so it's not really a whole lot of data. But there could be cases where you're working with a million data points or 10,000 images and so on and so forth. In that case, you don't want to be loading all that information into your computer's memory, because it's just going to slow down your computer. You may get like a memory overflow error, or out of memory error, so on and so forth. So what the MathWorks has done, and in MATLAB, you have these things called data stores. So you've got array data stores, which is what we're going to use here, which is just it's kind of like a pointer where it points to the data that's already stored in memory. But this array data store is we're able to pass that through our training functions. But we also got data stores for images, for signals, so on and so forth. And I highly recommend you go take a look at the documentation for it, because it can be very, very useful. Because you don't have to load all that data into your memory. Okay, and then so we've got two data sets. The X stands for the predictor, which is what we said, element 1 to n-1. And then the next is the response, which is the Y train, and that is second element to the end, right? So 2 to n. And then we combine both of those into a data store that we will pass into our network. So this is all the data portion of our code. Okay. Now we're going to take a look at the Deep Network Designer. So I'm going to run this section real quick, and I'll show you what the Deep Network Designer app looks like. But at the MathWorks, we love apps. Everything. If you click on this apps tab up here, this is loaded, but let me. If you click on this apps tab up here, you'll see an app for a whole lot of different application areas. So you can look at, you can make your own apps if you want to. And there are plenty of resources on how you can do that. But you see, these are machine learning and deep learning apps, maths and stats, control systems, robotics and autonomous systems, automotive, signal processing, etc. Computer vision, so on and so. So we love apps. Everything that we do, we try to have as many apps as possible. Okay, so I'm going to open up the Deep Network Designer real quick. We're on the start page now. What we're going to do is we're going to build our network from scratch, right? So you can either use some very popular networks that have already been built. So SqueezeNet is one, GooglyNet is one, ResNet. There's a whole list of them, and you can start from there. But we want to build our own, so we're going to choose this sequence to sequence LSTM, right? So this is a kind of network. It'll help us for this particular problem. So as you can see, this is what our network looks like constructed in here. Okay. Now, if we go back to what I spoke about at the start, where we were talking about the two different problems that we are facing, or the two different deep learning problems. One was classification, and one was regression. Does anyone have an idea as to what kind of a problem this particular problem is? Is it a classification or a regression problem? And if you know, please pop them in the chat. I'm gonna give it a second. There we go. Stuart Fong. Stuart, are you the guy that took part in one of our other hackathons and send me an email about writing a blog? If yes, thank you very much. But yes, regression is correct. So what we're going to do is what we're going to do is we're going to get rid of these two layers from us. So we've got the softmax layer and the classification layer. We're going to get rid of them, and we're going to find in our layers here the regression layer, right? So we drag it in, connect up the two, and this is our network. We're good to go. We can play around with some parameters. So we know that our input is going to take in one single element. As we said, we use month n-1 to predict month n, right? So it'll be one input, or input size is 1. And similarly for our fully connected layer, our output size will also be 1, right? So those are just some defaults that are in there. We're going to adjust this to what we want. Okay, so we've set this up. We're good to go. We've got our network design. Now, if you are if you are someone that likes to write code and doesn't like to do this, do these sort of pointy clicky things, you can export this network as code. So you can generate code for it, and what will happen is you'll essentially get a live script that has all this, has that network built. So it's kind of nice because you generate the code, you don't have to sort of go through all those clicks every time, right? Now, next step is the data set. We're going to go and import our data. We're going to import from data store, which is what we created. And as you can see, it's asking us for training data and test data. We're just going to use the combined data store and not going to have any validation data, right? This is because we've already got a test set on the side, so we're going to leave that out for now. Okay, but let's choose import, put that in. So as you can see, we've got 448 elements, which is 90% of our data set, or close to 90% of our data set. Okay, now we can go ahead and train this network. So first, you got to start with some training options. So these are those hyperparameters that we spoke about. There's some solvers. SGDM is stochastic gradient. ADAM and RMS prop are different various solvers. I recommend you go and take a look at the documentation for what these mean. But I'm going to choose the ADAM solver for now. Let's increase the number of epochs to 200, just because this, or maybe even let's do 500. Just because the number of epochs is the number of times it'll cycle through the training process. Let's keep the mini batch size as is. Let's do gradient threshold of 1. And I think let's change the initial learning rate to 0.0. Okay. So we've just set some parameters. Again, I don't really know what's going to happen. We're just going to try these out and see what happens. These are good because you can just sort of try them out and see what happens. I've got this execution environment. I have a GPU on my computer, so I'm going to choose that. But you can just as well choose a CPU or whatever. Even if you've got multi GPU, you can do that. So I'm just going to choose a GPU because I've got one, and it'll be a little quicker. But let's go ahead and hit train. And now, as you can see, it is going to start training this network with the data that we've provided, and it'll throw up a training plot as this happens. So essentially, what this plot is you've got the root mean square error, and then you've got the loss function. Now, the idea is that this root mean square error has to go as far to 0 as possible, and the loss also has to go, has to converge at 0 or try and get as close to 0 as possible. And as you can see, this is fairly quick. I'm using the GPU on my computer, but the training, it took us about, it's already done. It took us 24 seconds to train. I thought it would take a whole lot longer, but I guess not. Okay, so now what we've done is we've trained our network. The network is ready to go. Let's export it into MATLAB. Now, what you can do is there are different ways in which you can export this. You can export this trained network to MATLAB. You can generate the code. So all the training code that we wrote for this, you can generate that in MATLAB as well. Either export it to Simulink, which is our other product, or then create experiments for hyperparameter tuning. So we're not going to go into the experiment manager. You can take a look at it. It's another app. Just because we're kind of, it's not in the scope of this presentation, but it's something if you want to explore, by all means, go and take a look at it. But we're just going to export the train network and its results. And we should see this train network _1 in our workspace. So I'm going to go, and as you can see here, this train network _1. So this is our LSTM network that we've got here, right? So let's go back to our script, and take a look at all of this kind of fun stuff. So we've seen our training plots. So now let's go ahead and start using our network to predict the future, right? So we're going to do that same statistics operation, the standardizing it operation that we did, but now on the test set. So I'm going to go ahead and run this section real quick. And now what you see in here is, and the whole section is done, but I'm going to walk you through the code. So this predict and update state, this is we can open this up real quick. but essentially, or maybe we can even do a help on this. So it'll be a little better. But if we see what this does is, so what this function is doing is it's predicting a response based on your trained network, and then using that response to update the network state. So because essentially what's happening is, you say you identify or you predict data element number 501. Now you want to predict 502. You want to use that 501's data to predict 502. So that's essentially what's happening in that function, right? It's helping you forecast and keep moving forward. Okay. So this is that predict and update state. This is the network that we're giving it, the train network, and then the X train, which is our data set, right? And we're passing this network and we're passing this network and data set combination into our and our Y train back again into this predict and update state. So we're using the response to update the network, if that makes sense. Okay. So we can go ahead and run this. All that we're doing here is we're just doing this in a loop, so that we go to the we sort of we run this predictor on every element of the test data set, right? So it's just looping through that test data set. And then what we're doing here is we're basically unscrambling that standardization that we did. So earlier we subtracted the mean and divided by the standard deviation. Now we're just doing the opposite of it, right? And then computing the RMSE. So RMSE is root mean square error. So what is our prediction minus the test, which is what we know. So that's our test data set is what we call ground truth, right? So prediction minus test, and then calculate the RMSE error. Okay. So now what you'll see here in this plot is everything that's blue was stuff that we already knew. Okay, because we had only given the network 450 data points, and everything that's in red here is what our network has predicted. Oops, let me pop this out so we can zoom in and see. If you look in here, all of these red dots, all this red data set is what our network has predicted. Okay, and we can go ahead and take a look at what that actually means in terms of an error. So the plot here is the blue line that we have here is what our actual predictions are. So our ground truth is, and then if you see the red line, this is what our forecast is, right? So this is what our network is telling us, and this gives us the RMSE error of this. So it's not the best network, but again, we've only given it 450 data points. You give it more data points, it's going to be able to be more accurate, if you will. Okay. All right. So this is real quick how you can sort of use MATLAB to build a network real quick. I'm going to stop for questions and then go back to our presentation and show you some user stories. Okay. I don't see any more questions in the chat. Okay, cool. I'm just going to go and talk about some user stories that we've seen from the past. So we sponsored New Hacks 2020 a while ago. So it's obviously in 2020. And we had this team of students that won the Best User MATLAB Award at New Hacks 2020. And they essentially, when this hackathon happened, we were like right in the middle of the pandemic and everyone was learning virtually. And they built an app that would help professors know if a student on a Zoom call is paying attention or not. So they essentially built a neural network that does face detection and activity classification. So if the person's looking straight at the camera, it says that they are engaged. If they're looking to the side, as you see in the picture, it says that the person's distracted. And it feeds that data back to the professor in real time to to tell him if his or her class is interesting to the students or not, if they're paying attention or not, and he or she can use that information to make his or her classroom experience a lot better. And they used MATLAB with Unity. I know there's a question about Unity earlier, but they actually use MATLAB as the back end to do all the computations and then the neural networks, but Unity as a front end to build a nice app that the professor, or nice interface that the teacher can use. And two of the people that actually took part in this hackathon and built this hack for us, or built this hack at the hackathon, are now MATLAB student ambassadors. So if you're interested in becoming a MATLAB student ambassador, take a look at our careers page. We might have an opening at your school, it's a paid job. So it's not bad at all. You can there's a blog to this that you can take a look at about how they built it and so on and so forth. We also another example, and this was something that I really like, because I can never decide which movie I need to watch. But this group of students from Texas A&M at TAMU Datathon in 2020 built an app that would essentially take in a bunch of it's essentially taken a movie poster, and then it'll give you recommendations for other movies based on that poster, right? So it was pretty cool, because you give it a Superman movie picture, feed it to the app, and it's able to tell you that, okay, you might like an Avengers movie, right? So it's using image processing and this technology called autoencoders to essentially take a look at the features in the poster and then identify another poster that has the same features. Okay. So what are some resources for you to get started at the hackathon? So I know we only spoke about deep learning. We only had an hour. I can talk about MATLAB for 12 hours because there's that much amount of stuff that we can do. But if you're on GitHub, please go and take a look at the awesome MATLAB hackathons GitHub. I believe Rosendo popped that into the chat at some point. So yeah, you can go and clone that repository. You'll see, I actually opened that up for you right here real quick. But if you go to this repository, one is if you're taking part in a Major League Hacking hackathon, this is where you can get access to your license. So there's a complimentary licenses available for Major League Hacking participants, and you can either use MATLAB Online or the MATLAB Desktop. So what I was using was MATLAB Desktop, but there's also a MATLAB Online license available there, which you can use, and you don't need to download the whole product. Here is a list of some of our supported hackathons, but then there are getting started resources. So these are complementary to our tutorials. I know someone at the start asked if you need to know MATLAB or machine learning. These are a whole list of topics that you can do. You can learn in under 2 hours, and they're all free. And you get a certificate at the end of it saying that you've gone through the on-ramp. So these are for a whole bunch of topics, but we've also got some for Simulink, and they're really nice, and you can take a look at them. As you can see, we've got some videos. These are the blogs. So if you click on this link, you'll see those 2 user stories that I spoke about. We also got a link to File Exchange, which is where you can find code that people have already made. We're also on GitHub, so you can look over there as well. But then we've also got resources by application areas. So say you want to do something with data science or data analysis or AI, app building. You want to use it with Python. We've got some tools for that. You want to use it with hardware. Actually, we didn't talk about it, but MATLAB and Simulink can talk to hardware directly. You don't need to be able to learn how to code in whatever, in C++ or C or whatever language your hardware is using. You can just sort of build it in MATLAB and Simulink and hit a button and it'll build the code onto the hardware. For finance, for climate change, Internet of Things is our or ThinkSpeak is our Internet of Things platform. So there's a whole lot of resources for you at this GitHub repository. I highly recommend you go and clone it, so you've got it for future hackathon users as well. Okay, awesome. I spoke about the MATLAB Central community. So we've got MATLAB Central is on our website. There's something called MATLAB Answers, where people you've got a whole community. There are 2 million plus MATLAB users around the world. So a lot of people that are using MATLAB, a lot of people that have probably already solved what you're trying to solve. So if you have a question that you can't get an answer to, post up there. Most questions get answered in less than 60 minutes, just because of the volume of people on there. File Exchange is where you can download code that people have already made. It's our version of the open source. So you can download the code for free. You can use it. There are obviously license restrictions based on what that user has put it up, but it's all mentioned in that exchange in that code artifact, so you can take it from there. If you're a nerd and you like to do programming games, we've got this thing called Cody, which is it's like a fun thing where you can sort of try and solve math problems. There are some blogs that you can take a look at, and if you're interested in the Internet of Things or IoT, take a look at ThinkSpeak as well. Okay, but all in the MATLAB Central community. You can go and take a look at that on our website. I spoke about those complementary on-ramps. There are only 3 mentioned here. There are, I think, over 10 on our website. So you can Google search MATLAB on-ramp and it'll take you there. But these are quick 2-hour introductions, assuming that you know nothing about the subject. So they're very good for beginners, and you get a certificate at the end saying that you've completed it. So that's kind of nice. We've got some career opportunities for students and new grads, if that's what you're interested in. We've got this thing called the Engineering Development Group, where we hire basically anyone with any engineering degree, right? So we're looking for either bachelor's, master's, or PhD, people that have PhDs in computer science, in any major engineering stream, or applied math or physics majors. And this is our entry-level program. So please, if you're interested, please go and apply. We've also got a bunch of internships. I know the summer's kind of over. I think this year we hired like 500 interns, maybe 500 to 600 interns. And it's going to keep continuing. That's not something we're going to stop. So we're going to still hire a bunch of interns next summer. So if you're interested, please look at our website for it. And then we've also got the Student Ambassador program that I told you about, which is something that you can work on while you're still in school. And you can take a look at our website for that as well. Okay, so that's the end of my presentation. I'm going to try and see if there are any more questions in the chat. If not, we can give it a couple more minutes to ask questions. There's a person that asked, can I ask you a question not related to this topic? Yes, you may. Absolutely. I'll try to help you as best as I can. Yeah. You guys all have the most creative names that I can never pronounce, and I don't want to murder it. So, Haki-san, I guess. If you have a question, please feel free to ask. Okay, I guess not. All right, everyone. Thank you so much for taking the time to come out and hear me talk on a Friday afternoon. I wish you guys all the best for the hackathon that's coming up, and yeah, please use MATLAB, and you'll get some nice swag, and we'll also get a chance to feature you on our blogs, like we did with Stuart, who was on the stream a little while ago. So yeah, thank you so much, guys. If you'll have any questions, please reach out to there's an email address on the GitHub page. It's hackathon@mathworks.com. We'll be happy to answer you some questions. Oh, Malik has asked a question real quick. What are some of the opportunities available in India? So the EDG program is available in India. We hire a lot of people in India. We've got, I believe, 3 offices: one in Bangalore, one in Hyderabad, and I believe one in Pune. Um, um, but we have we have a bunch of offices there. We hire a lot of people over there. Take a look at the engineering development group program, because they actually have that in India, and you can apply for that once you graduate. Uh, we don't have any ambassadors, any student ambassadors in India right now, but we're working on that, and we're hopeful to have something soon.
All right. Well, thank you so much, Connell. Really appreciate you jumping on the stream and showing us pretty much like, all you need to know about MATLAB. I know there is like a lot more to know than that, but it just seems like there is so much you can accomplish using the MATLAB platform. So really thankful to have you on board. And also, like, once again, really thanks for showing us what the difference is between machine learning, deep learning, giving me a solid perspective on all the things that I don't know in life, but it's okay. I won't hold it against you. Thanks once again, Connell. I really appreciate your help. We'll see you next time, okay?
Yep. All right. See you guys. Thank you so much.
All right. Okay. And once again, y'all, thanks to Connell for joining us. Just a couple of things that I did want to show y'all before I jumped off the stream. You can check out almost everything that Connell was mentioning during the stream at hackp.ac/mathworks. Really, it's gonna show you the entire GitHub repository that they put together for all of the hackathon resources that you need in order to participate, not only in the best use of MATLAB prize category, but also just to use an excellent tool that'll allow you to really put out an awesome hackathon project. So with that being said, it's going to be it from our end. It's always a pleasure to bring this type of content over to the community. So we really appreciate you sticking around and supporting our presenters, and also supporting our hackathons, attending them, and using the technology that we make available as far as the resources are concerned. So once again, Rosendo from MLH signing off. Have a great weekend, y'all, and enjoy.